Space weather! Looking at Sunspot 2733. Close-up style in 94 angstroms. Its activity is not yet completed, and we see it launching another high-level B-class solar flare. Also, we've got a large coronal hole incoming, and the wind stream from that is expected to arrive early tomorrow morning. It's a big coronal hole. Let's look at the magnetic lines. First, note the complexity associated with that sunspot and the lack of complexity associated with that coronal hole. Looking down the barrel of a Grand Canyon coronal hole right now. And here's the view of the sun at 193 angstroms. The wavelength many consider to be the most comprehensive single wavelength. And let's look at the real-time solar wind here. Phi angle is indicating a magnetic connection with the coronal hole. That's the source of the ongoing earthquake risk. Solar wind density has jumped up a little bit to around 5 protons per cubic centimeter. And the solar wind speed is still quite low. It looks like it is around 375. Let's look at spaceweather.com, where we will note that 10.7 centimeter radio flux has gone up again, now at 76. Next, we'll have a look at spaceweathernews.com. See that X-ray flare. There were actually a series of B flares here. And we will look at it on the X-ray monitor momentarily. Magnetometer is still very smooth. And the KP has been at 0 almost the entire last 24 hours. A small uptick to 1 and right back down to 0. We'll be looking at cosmic rays as well. Here's the electron flux looking also very smooth. And we're expecting some perturbations in everything coming up soon. The F2 layer is looking anomalous down here again in the South Pacific, as it has for days. This part is surprisingly charged, and this part is surprisingly discharged. Now, before we animate the gong too, we'll look at the last frame here. You can see that the magnetometer is about to spike. It will be reflected in the GOES magnetometer soon. You see the way the Earth's magnetic line here is curving into this bunched up region. It's going to eventually snap across. Now, if it snaps into this bunched up region, we won't see a big difference in the magnetometer. But if it spikes down this more dense region, there will be a quick magnetometer spike, followed by another relaxation, and then in about 36 hours, another spike when this region is entered, magnetically speaking. Again, these things can change without any warning at all. However, based on current trends, that's what it looks like is happening. Keep in mind, this data is 1 hour and 29 minutes old. Next, we'll look at the magnetosphere movies, as we've been seeing some very weak magnetosphere. Here's the velocity. Next, we'll look at density. We will see some very low density waves coming in here. That's the low density portion of the solar wind. It was fluctuating quite a bit in the past 12 hours. And toward the end of the movie, we see more of a return to a normal density. Here's the pressure, looking very weak, not really surprising there, especially at the beginning. You got normal velocity and low density, you're going to end up with low pressure. And there you have it. It should kick up by the end. And there you see a slight pressure increase happening. A little bit of yellow forming at the bow shock. Next, let's look at Geospace. Ground magnetic perturbations here. Looking very weak at the ground level. Barely even a blip. And then a slight increase there at the end. Let's see how it pans out globally. I'll let that play through one more time from the beginning. Moving on. All right, we're going to go back about 18 hours here in earthquakes. See a 5.5 in Colombia, 4.5 in Peru, near the areas we warned. Although we're still waiting to see a 7 because we've been experiencing a drought in high-level earthquakes here. There's one in Mexico, 5.0, 5.0 in Japan, 4.6 in the Philippines, 4.5 in Guatemala, and there's another very deep quake in Fiji. I still say this region is the most likely spot for a 7+, and there are anomalous looking low pressure systems there, making it even more likely. Next, let's look at volcano discovery. It looks like a little volcanic downtick here. We've got Sakurajima with a 4,000-foot ash plume, Reventador with intermittent volcanic ash clouds, and it looks like continuous emissions from Planchon Peteroa. So a bit of a downtick there, although keep in mind yesterday Shivaluch was erupting to a 20,000-foot ash plume type level. So be keeping an eye on that. Let's look at the Space Weather Enthusiast dashboard to see that X-ray flare that was kicked off by Sunspot 2733 as it departs on the western limb. Should be a series of 3 pulses, the third of which should be the largest. There's 1, there's 2. Perhaps that was 2, then 3. In any case, we'll let it play through again. Could be the last bit of activity we see from Sunspot 2733. That was all 3 flares. Moving on. While we're here, let's look at the Enlil forecast. We do see a prediction for an increase in plasma speed starting on the 31st, and the plasma density uptick starting tonight, actually. Tomorrow night, that is. And there's your Enlil prediction. Keep in mind these are models showing us density and velocity of the plasma at Earth, at stereo A, and at stereo B. Next, check out RT.com for an article about Lake Vostok breakthrough. Russian scientists drill a clean hole into Antarctic subglacial basin. Whoopsie. I guess the last time they completely contaminated their borehole. So this time they're pretty confident that they clearly did it. Looking for microbes in the liquid water of Lake Vostok, which, despite being under tons of ice, thousands of feet of ice, it's actually still liquid because of the pressure. We'll leave links to the article. Next, we've got one from SciTech Daily. Sophia, a telescope, lifts the veil on star formation in the Orion Nebula. Check it out. So we've got this bubble. Which the star is blowing out where no other stars are forming in there. And then out here on the outskirts, you've got star forming regions. NASA's Stratospheric Observatory for Infrared Astronomy. We do have trouble seeing through these dust clouds of hot ionized dust. Their magnetic fields obscure the objects behind them, and so one of the ways around this is to use infrared telescopes. We'll leave links to that article also. Next, let's look at Science Alert. There are 3 global pandemics threatening humanity, and they're all dangerously linked. What are these pandemics, you ask? This guy didn't ask, because he's dead. Or she. Turns out the 3 pandemics are undernutrition, obesity, and climate change. Yeah! Alright. Thank you, Nonsense Alert. Jeez, we got undernutrition, we got obesity, and we got climate change. Dag. Now that is one hell of a combo. Anyway, the moral of the story is people are so fat that they're malnourished. People are so malnourished that they're fat, and the planet is so cold that it's hot. Looks like Phys.org is finally picking up what people like David Devine and Christian Westbrook are putting down. Extreme weather and geopolitics major drivers of increasing food shocks. Yeah. We've got food shortages all over the world right now, caused by things like knee-deep hailstorms. So, thank you, Phys.org, putting up an article here that is actually reflecting one of the largest problems mankind has to face. Because during a solar minimum, crops don't grow as well due to solar irradiance, not just because of the extreme weather caused by attenuation of the jet stream, which is caused by a weak magnetosphere, by the way. Speaking of attenuated jet streams, here's the GFS model of the 250 millibar wind. And this is a forecast through Valentine's Day. I would draw your attention to the persistent low, which is just following the plate boundary here, which is why we keep warning for a 7+ earthquake in that area, especially with the deep quakes from Fiji. Thanks, Tropical Tidbits, for the great GFS models. Next, let's look at the NASA GOES water vapor. You can see some compression being caused in this area because of these dry, massive air regions in here, holding the moisture in place. Also, we do see interference lines going across a satellite view. Is it from cosmic ray flux? Not sure, but we will be looking at that momentarily. Also, you can see the jet stream is now shifting farther to the east, pushing snow across Pennsylvania into the eastern Pennsylvania regions. And this atmospheric river is finally moving off into the Atlantic. Here's a value-added service we like to provide sometimes from AccuWeather.com's U.S. Doppler radar. Give you an idea what's happening as far as precipitation in the U.S. See this long band of moisture stretching down the entire east. A little bit of mixed precipitation in Northern California and Nevada. And this area is frozen. Now, cosmic rays cause the Earth to be colder. How do they do that? When more cosmic rays get into the atmosphere, they create ionization pathways, which cause clouds to form, especially low clouds such as stratocumulus. And the more clouds you have, especially at low levels like that, the more radiation you bounce back into space. This is called the Albedo Effect, the reflectivity of the Earth's surface. Cosmic rays make the planet colder. Now, why are we looking at this? Because there's a lot of channels out there claiming we're at the highest cosmic ray levels ever measured. And you can clearly see right here, at least at Oulu, Finland, late 2009 was clearly the highest, a 6% above normal level of cosmic ray flux. You look at where we currently are, we're not even at 5% above the normal cosmic ray flux. Now, why is this important? This could be some sort of a proxy for something larger than the sun. For instance, if the sun is externally powered, perhaps the sun is following some sort of a magnetic filament that's invisible from our perspective from Earth. If so, the position of the sun on this filament is going to have a huge effect on the amount of incoming cosmic rays. That said, let's look at the current data at Oulu. You can see we have had an uptick in the past day. Very small one right at the end there. Let's look at Antarctica. DOMC. We see a spike in DOMC as expected with a KP of 0. DOMB. Actually agreeing with DOMC for once. All right. Here's your Athens neutron monitor. This has actually gone down in the past 8 hours. Here's Mexico, which actually has a down spike at the end. Now let's take a look at Mexico City to see if it agrees with Oulu, right? Let's go back to 2007, January 1st, 2007, until the current. Now, the times are going to be all jumbled up because for some reason this monitor does not like to draw the graph correctly. Now, granted, you can't see what the dates are down here, but this is from 2007 until current, and you can see that in this region here, we had higher cosmic ray flux than we have currently. Close to as high, but not as high now as it was back then. Just saying. Lastly, here's Moscow's current readings. Keep in mind, Moscow's neutron monitor always has a larger range than the other cosmic ray monitors that we typically look at. So now let's get some more close-up images here of Sunspot 2733 as we bid it farewell. A great view here in 171 angstroms. Thanks for watching, everybody. We can't monkey around because we got to get the video uploaded. We got to get it edited. We got to get it uploaded. We'll be doing it all again tomorrow. Thanks again for tuning in. Remember, when you're staring at a departing sunspot, don't drink. And if you drink, stare at the departing sunspot anyway. And don't drive.